My name is Jay Gopalan, and I definitely disliked math most of my time growing up. I always did decently in my classes, but I felt like it was kind of abstract, pointless, and dry. Like most Americans, I was sorely mistaken. When I was about 12, I encountered a fantastic piece by Paul Lockhart called Mathematician's Lament. In this, he argues that math isn't just a set of equations to memorize or processes to follow or mechanical items, I guess, but more of an art. I think the point of math and the point of studying math is not to learn a body of knowledge that already exists, but to learn a way of thinking that looks at the world from a totally different perspective from anything else that comes naturally to humans. So, for example, if you want to understand a circle, right, you don't care about what the materials of the circle are, or care about where the circle is, or when the circle exists, or what the circle is being used for. All you need to do, if you're thinking in a mathematical way, is imagine a set of points equidistant from a center. You know, imagine the concept of a point, and imagine some property of these points, and you have a circle, no matter what. It's totally divorced and totally not tied to anything in the real world, which is, in some ways, the most purest and beautiful form of art that you can get. I think all of math is this process of abstraction and simplification to boil down this crazy thing that we call the universe into discrete structures that we can work with and understand. I think there are lots of ways that people have of understanding what truth is, what perfection is, what beauty is, and math is, one way that might work for this, but by far the most well understood way, by far the way that we have, by far the way of garnering the truth that we have the most certain knowledge about, and that's incredibly beautiful and incredibly creative and incredibly thrilling to get to explore. In this lesson, we cover two of the most basic concepts in math, which are the shape, geometry, and the number and number theory. We start by seeing how these concepts arise naturally from structures and from ways you can think about the world, and how just by defining like a number as a reference to something, no matter what that something is, you can find some interesting properties of how these numbers react and how the structures build off of each other to form interesting concepts. For example, why is an even number plus an even number another even number? Which we don't think about that much, but it's kind of insane that we can prove that no matter what this group represents, the alternating elements of this line of numbers plus the other alternating numbers plus the other alternating line of elements will put you in the second group instead of the first group of alternating elements. No computer in the world can calculate an infinitely large number, but through reason and through imagination we can figure this out. And so I think that this is one of the most interesting things to study, and I hope that you can discover that too.